Hello, this is Mrs. Scarple, and in this video I'm going to go over how to graph a parabola from vertex form using the vertex form of the equation and identifying the pieces of information we can use. If you recall, for transformations, when you have x plus 3 squared, that's going to indicate a horizontal shift to the left 3 units. And the minus 4 is a shift down 4 units. Now this information also leads me to my vertex. If I'm going to the left 3 units, that means the x value is going to be negative 3. And down 4 units means the y value will be negative 4. I can also identify that the axis or line of symmetry will be x equals negative 3, so my parabola will be symmetric about that line. I can also tell you that because it is positive in front of the expression on the right side, it will open up. And the anchor values we use for parabolas are 1, 4, and 9, unless we have stretch. I do not see a value in front of the expression on the right side, so there is not going to be any stretch with this parabola. So I'm going to begin by plotting that vertex, left 3, down 4. If you would find it helpful, go ahead and draw that axis or line of symmetry through that vertex so that you see what you're working around. To get other points for my parabola, as I move 1 to the right, I'm going to move up 1. Move 2 to the right, I'm going to move up 4. 3 to the right of that vertex is going to be up 9. And because we know parabolas are symmetrical, we can plot points on the other side of the line of symmetry or axis of symmetry that are mirror images of the points we plotted on the right. And then we can plot our parabola. Let's take a look at another one. This one is going to have a horizontal shift to the right 5 units. And up 7 units. That means our vertex will be 5, 7. Our line of symmetry or axis of symmetry will be x equals 5. But notice that this equation has a negative in front of everything on the right side. That tells me that we have a reflection, so it is going to open down. Our anchor values are 1, 4, 9, and if we double check for an A value, There isn't one attached to this negative, so we will use 1, 4, and 9. So first I'm going to plot my vertex, 5 to the right, and 7 up. My line of symmetry will go right through that vertex. You might find it helpful to draw that in. And this time, when I go to the right of my vertex 1 unit, I'm actually going to go down 1 unit. If I go to the right 2 units, I'm going down 4 units, and 3 units to the right of my vertex is going to take me down 9 units. And I can draw the mirror image of those points on the other side of that line of symmetry, and I can draw my parabola. And one more, again, identifying any translations, we're going to have a shift to the right 6. We're going to shift down 8 units. Which gives us a vertex of 6, -8. The axis of symmetry is x equals 6. It is a positive 2 in front, so this is going to open up. And because of the 2, our anchor values will change. We're still working off the 1, 4, 9, the original anchor values, but now we have to stretch them. So I'm going to multiply them by 2. So the anchor values I will use in this graph are 2, 8, and 18. So starting with my vertex, 6 to the right, 8 down, 1 unit to the, actually let me draw in that line of symmetry so that we know what it has to be symmetrical around. Then, when I go to the right of my vertex 1 unit, I'm going to go up 2 units. When I go to the right 2 units, I'm going to go up 8 units. When I go to the right 3 units, I'll need to go up 18 units if my graph allows. And it does not. So I place my mirror images on the left side, and I draw my parabola, making sure that it is still a curve at the bottom and not a V. We want it to represent a quadratic function, not an absolute value function. And this concludes the video on graphing parabolas from vertex form.